Gensendorf, a small town near Vienna, is home to OMV's treasure chest. Core samples from worldwide test drills over the last 70 years are stored here. They paint a fascinating picture, up to 8,500 meters deep within the earth.
Spannend macht es das eben die Vielfalt, die man sieht. Ja. Wenn man in der Lage ist, in diesem Gestein zu lesen wie in einem Buch, dann sagt ihm das extrem viel. Ja. Jetzt sagt man zum Beispiel, dass ich hier hohe Strömungsenergie hatte, dass daher der Sand, hier habe ich eine geringere Strömungsenergie, auf einmal können sich hier Tiere ansiedeln. Ich sehe zum Beispiel Reste alten Ozeansbodens, die früher in mehreren tausend Meter Meerestiefe gelagert haben und jetzt sich mehr als 3 Kilometer unter der Erde befinden. Oder hier zum Beispiel ein Gestein aus einer Zeit, als die Tier- und Pflanzenwelt gerade dabei war, das Land zu kolonisieren. Also das ist das Spannende, das Aufregende an der Sache.
Even today, seeing and feeling the rock is an irreplaceable method of identifying deposits. This still holds true, even though other, more modern methods are now used in the search for oil and gas. If the soil analysis looks promising, the next step is to set up a drill site. This is about the size of a football pitch. The tower needed to drain the drill pipe can soar up to 60 meters high in the sky. The beating heart is a hydraulic lift system which maneuvers the drill pipe. It can handle loads of up to 450 tons and more. This means it could easily lift the world's largest aircraft with 800 passengers on board. The actual drive unit would be the clear winner in a tug-of-war against 120 cars. The levers are made from steel pipes and achieve 50 to 120 rotations per minute, generating immense pressure just from their own weight. This is how the drill bit battles through the rock meter by meter. Inside, the construction is hollow like a straw, so that the drilling fluid can get right to the bottom. The cycle involves 3,000 liters a minute, equivalent to the output of 400 pressure washers from a DIY store. The drilling fluid fulfills many functions. It carries the crushed rock upwards and cools the drill bit, but most importantly, maintains pressure in the drill hole, as the pressure needs to be slightly higher than the ambient hydrostatic pressure. This stabilizes the drilling. Nevertheless, there are still some difficult situations to overcome. Sudden changes in pressure are a real challenge. The pressure at a depth of 500 meters is normally 50 bar. The pressure is 200 bar in rock layers at 2,000 meters. But over millions of years, these rock layers sometimes shift upwards. Instead of 50 bar at 500 meters, you suddenly have 200 bar. But thanks to the blowout preventer, the material doesn't shoot out of the well. The device immediately seals the wellhead until the drilling fluid has exerted enough opposing pressure to continue working.
Also zu den Bohrer sagen hier wir im Bohrprozess Meißel. Wir benutzen hier sogenannte Rollenmeißel und auch PDC-Meißel, wie man den hier sieht. Das heißt, diese Kanten hier, diese dunklen, bestehen aus Industriediamanten. Diese Meißel haben den Vorteil, man hat keine rotierenden Elemente und man kann mit diesen Meißeln, wenn man Glück hat, bis zu 2000 Meter bohren. Natürlich, wenn man Pech hat und dieser Meißel erwischt die falsche Formation, was sehr hart ist, dann kann der Meißel nach 10 Meter auch kaputt sein.
The sensors behind the drill bit allow for high-precision drilling, constantly getting information about the direction and gradient. But how can we access these measurements? Using a device which can drain off excess drilling fluid. This creates pressure pulses in the liquid which are received at the surface. Theoretically, this Morse code allows the team to pinpoint a keyhole 2,500 meters away, drilling within half a meter's accuracy, according to experts. These deep drills are often at depths of 2,000 to 3,000 meters, but the record is a staggering 12,262 meters. Not even the peak of Mount Everest, the highest point in the world, can compare. But going in a straight line is not always the best option. Directional drilling, or slant drilling, offers tremendous flexibility. You can drill in different directions from a single starting point. How does it work? The drill bit is the only thing which turns. Driven like a water wheel by the immense power of the drilling fluid. Behind this, there are telescopic control ribs used to control the bit. Angles of up to 90 degrees are possible at a length of 300 meters. The steel of the drill pipe has enough flexibility to handle these curves without any problem. Directional drilling is also good for the environment, as you don't need additional well pads and can therefore avoid further disruption to the surface.
Ja, wenn man die Lagerstätte erbohrt hat, dann wird der Bohrmeißel ausgebaut und dann wird die Bohrung physikalisch vermessen. Falls die Bohrung wirtschaftlich fündig ist, wird die ganze Bohrung dann mit Käsingen ausgekleidet. Das heißt quasi mit Stahlrohren verkleidet und verzementiert. Wenn man dann natürlich einen Erfolg hat, Öl oder Gas findet, ist natürlich das Erfolgserlebnis umso größer. Ne?
In principle, deep-sea drilling is comparable to onshore drilling. The key difference is first overcoming the depths of the sea. Different rigs are used depending on the water depth. The main difference is how they are fixed to the seabed. For example, this can be with a solid frame or steel cables. The largest oil rig has a height of 472 meters and would tower far above the Empire State Building in New York with its 102 floors. Special drill ships or platforms are used when it is not possible to fix a rig. They have fast-acting, pivoting propellers. In combination with satellite positioning, these replace the anchorage and maintain the precise position whatever the wind or weather. But whether on land or sea, whenever deep drilling hits on oil or gas, it's thanks to the experts whose knowledge and skill have identified the right place to drill.